Hello folks again. We're continuing our Ironic series with Ironic at your service to talk about our advances in a process called servicing. Today with you, me, Dmitry, and Jacob. Unfortunately, Iury, who is the original co-author of this presentation, could not attend, so I'm replacing him. Hope you're not tired of seeing me, at least some of you. We'll talk about why we're doing that. We're talking about challenges that we face while doing that. We're going to talk about some details of the implementation so that you know how you can use that. And we'll actually show the whole thing and talk about future direction. So, short introduction, obligatory slide. What is Ironic? Ironic is a baremetal provisioning service under the OpenStack umbrella, heavily used both in the OpenStack context and standalone in projects like MetalCube. We handle great variety of various node operations like discovery, inspection, provisioning, decommissioning, and today we're going to talk about extra operations, especially for already provisioned nodes. We're going to briefly mention MetalCube. If you want more details, there was a talk yesterday at 5 p.m. Watch the recording. It's an incubating CNCF project, bare metal provisioning for Kubernetes API. It uses Ironic as its backend. It supports, most importantly, firmware upgrades, and it supports the process we are going to talk about, which is servicing. And we're going to show examples of both Ironic directly and Ironic through MetalCube. So why are we doing all this? Our mission is to make sure that the bare metal cloud is easy to manage and is always in a good operational state. Obvious part of that, and a very common request, is enforcing firmware versions and firmware configuration, aka bias settings as we call it in Ironic world. Specifically, keeping firmware up to date is essential for stability reasons, for regulatory reasons, for feature availability reasons, and sometimes downgrades are also required. Unfortunately, things happen, firmware can be buggy, or again, compliance reason may demand a certain version as well. Challenges, as always with hardware, things tend to be vendor-specific, and initial implementation are actually in vendor-specific drivers. We also were only gradually expanding the workflow availability of these operations. Initially, it was only cleaning, manual cleaning specifically, so operations you're running before deployment. And basically once, if you want to run them again, undeploy, deploy again. Nobody wants that, especially for firmware upgrades, which you sometimes need to apply yesterday, or at least right now. Yeah, it's a maintenance workload, it's a lot of downtime, obviously. Over time, first we got firmware upgrades at all in Bobcat release as part of cleaning, and separately we got a servicing feature which allows running operations, running steps, if you've heard the previous talk just from Jay 5 minutes ago. And we're essentially talking about merging these two together into a very cool feature. In Flamingo Cycle, we also added new firmware upgrades. So currently we have firmware upgrades for 3 components. We have BIOS/system firmware, we have BMC, which is a management controller, IO, and now new NIC firmware. I think it was tested with Mellanox cards, right?
Intels, I think.
It was 2. Alright, cool. Jacob has spent a lot of time improving some operation time. Probably mention it again. There was support for actually aborting operation, a lot of resilience improvements. And currently, the state of today, we support these operations, firmware upgrade, firmware setting were a bit earlier. On day 1, so when you just provision your nodes, and what we call day 2, so when your nodes are provisioned and you need to quickly, hopefully within 30 minutes, to run firmware upgrades. The 3 components I mentioned about before, and BIOS/firmware settings, things like, I don't know, cannot come up with an example.
SRV, something relevant.
So again, 2 options to apply. Basically repeating the same idea. Cleaning is Ironic speak for day 1, and servicing is Ironic speak for day 2, already provisioned. And of course you can do both. Some people prefer, usually BIOS settings go with cleaning, and from upgrades sometimes you have to do it on the fly. And I hope that gives you some idea of what we have done, and now Jacob is going to show how we have done that and how you can do that.
That's right. Thank you for a great introduction, Dmitry. I'll start with showing you some of the underlying APIs that we use to implement servicing. So essentially everything we do relies on Redfish. Essentially it's all between get, patch and post requests depending on what we do. So in order to fetch firmware information, we query system manager network interfaces. Then we use simple update to apply updates. And when it comes to applying BIOS changes, we patch the appropriate resource on some servers. That would be just the system. Some of them have a dedicated setting. So it really depends on the implementation. I'll give you some examples. I like learning by example, so I'm going to show you a couple example queries that explain the underlying mechanisms. Then we move on to demos. I'll actually show you how it works end to end. But here you have examples of those Redfish resource queries that I mentioned. So in the first one, we query the iDRAC firmware version with a get query. In the second one, you see updating the very same component. So in the response, you've got 710, and we're going to feed it, that's 71070, we're going to feed it 71090. After a while, server pulls the image, applies it, reboots the BMC, you end up on the requested version. So that's the underlying bits for the Redfish part. Now we take this and build upon it. The servicing part in Ironic is implemented through the provision API. So when we send servicing requests, what that does in the background is using this API, essentially sending a request to set the node to servicing state and specifying the stack which has the component we wish to upgrade as well as the image we wish to use. Now, taking a step up the stack, this is the CLI that allows you to monitor the current versions of firmware on the server. I updated the columns here to make it easier to display on the projector. You don't have to do it, it's a pretty simple command. Here we've got examples of the calls we would make to actually update the image as well as change settings. So the CLI for baremetal that you all know and use, depending on what we want to use, we use different interface. So for the firmware updates, we use firmware. For the settings, we use BIOS. And the last thing I'm going to show you in terms of CLI is, as Dmitry mentioned, Melo is a Kubernetes distribution of Ironic. That's how I like to think about it. And you can use all those features that I just shown you from that layer as well, utilizing Ironic running underneath. So with Melo, you've got the additional component of hub, post update policy, which defines whether you want to apply those operations as day 1 or day 2. So essentially, it's the same interface for servicing and cleaning, and just set it to what you need for your particular requirement. So here we're going to use servicing, so we set it on reboot, which means each time we reboot a node, the requested changes will be applied. And then we've got custom resources for firmware components and settings, and we can just patch them, essentially referencing the component and the image the same way we do with Ironic, and that results in those operations being applied as day 2 operations. So to finish off the CLI slides, you've got the interface that allows you checking versions as well. So similarly to what we had in Ironic, we have the same ability in Melo by tracking changes in the host firmware component custom resource. And with this, I'm going to move on to demos. Hopefully it all works. Those are long-running operations, so obviously I cut them by a fair bit to not to test your patience excessively. The first demo will show you the Ironic flow. So we've got a baremetal node. It's an iDRAC node, which you will see in a second. First, we're going to check what firmware version is currently running. See, it's on 2.19.1 BIOS version, and we're going to update this to a latest one. I'm also going to bring up the console so you can see what operations are performed on the node while Ironic is transitioning through state. So we use the same step you've seen in the previous slides. We're going to update from 2.19 to 2.24. We're going to watch the console, and I'm going to jump ahead so that the process takes about 20 minutes. We'll complete it in 3 for this demo. So I requested the upgrade. Now what's happening is Ironic is calling simple update in the background, and BMC is downloading the image. As soon as that completes, the node will reboot, and you will see the BMC working through the steps required to actually apply the BIOS package onto the hardware. Now you can see the console going blank. I'll run another baremetal list command. You'll see it switch to service wait state, which means it's waiting for the BMC to complete the operation. The server is power cycling, and it's gonna put into the update, as you can see right now. It's getting the image onto the hardware. It's already downloaded onto the BMC. Now it's loading it up into the BIOS. And once that's done, we need to reboot, and in this part we use ironic run disk. So essentially, after the BIOS update is complete, we need to do a compulsory reboot, and we use the RAM disk to track whether those reboots complete successfully. So what you see right now is the RAM disk. Once the RAM disk validates that the node has booted successfully, it's going to reboot again back into the image and go back to active, which you will see in the next minute or so. So you can see it's power cycling again. Now it's coming back from the RAM disk into the operating system image it had deployed initially. Once we hit that state, as far as Ironic is concerned, we're back to active. So you're going to see this shortly. There we go. So now it's just putting back into the image. So the firmware update operation has succeeded. To finish off the Ironic demo, we're going to check whether the version has been successfully updated. You will see this in the next command. And we started at 2.19. You can see tracking of the versions. It's moved from 2.19 to 2.24, so the update has been successful. This concludes the first demo. So you can see that the version matches the one that we requested in the step. And with this, I'm going to move on to the next demo, which will picture a similar operation performed with Metal Cube. And for a change, we're going to downgrade. We demonstrated successful upgrade. We're going to go a downgrade in the next demo, just to cover a wider variety of features. Similarly to previous demo, you can see the console and you can see the BMC as well. So here you see a similar interface to what we've seen in Ironic, but applied to Metal Cube. So we're working with bare metal hosts or DMHs, custom resources that are used to track our servers. We're checking whether the update policy is set correctly to on reboot so that we can perform day 2 operations. It is. And we're going to check what are the current versions on the machine. So for that, we use the host firmware component CR. So we're looking at BIOS as well. So we've got 263. This is a very different platform, so versions are different. It's a different generation of Dell. I had in this lab. And we're going to craft the patch command to change this. So we had 263, we're going to go with 235. So essentially going back to the initial version we had on the server when we first enrolled it. So the patch command has been issued. Now to trigger the application of the image, we need to reboot the node because that's what we have set in the host update policy. So you'll see the annotation. The annotation will trigger a reboot, and once that gets through, you'll see the console showing signs of a reboot. The node is still in operational status okay because I ran this command just before it reboot. Once I run it again, you'll see it transitioning to servicing operational state, which matches servicing state in Ironic. So now it's servicing. And you'll see a similar prompt in the BMC console indicating that the BIOS is being updated. Again, fast forward. This has completed, so put into RAM disk, validate that the reboot has succeeded, and then reboot back into the image that has been installed on the hardware before we started the operation. Still in servicing. and out of rebooting back into the image that's been on the server, we're transitioning out of servicing into OK. You can see the OS booting up. And then we'll just, to close it off, we'll check that the version has been downgraded as we requested. So as you can see, we can upgrade the firmware, which is what we mostly do, but also if we need to, we can downgrade, and it works either way. So you can see it's now back to the initial version. It's been on a newer version. So that concludes my second demo. We'll have the full screen. Different keyboard, sorry. You can just go to the next slide. Yeah, thank you. Sorry about that. All right, so that concludes the second demo. Let's talk about what we're intending to work on in the future to make servicing even better. So in the Ironic update section, we mentioned doing some work to handle BMCs becoming unresponsive after the firmware update. That works, but we're intending to expand it further, so we're not only waiting to make sure that things stabilize, but we actively check whether the BMC is responsive, and we check it in multiple ways. We're checking multiple resources because some of them recover more quickly than others. So we've got some in-flight patches which will hopefully merge soon. An important part we'll be working on is in Ironic standalone, we added service abort feature, which allows us to back out from an operation. Now we can't interrupt the step for obvious reasons when we're upgrading firmware, but say if we attempt a step and it doesn't work, instead of trying it till it succeeds, we can just back out from the entire operation and not do it. So right now we don't have that in the DMO yet, but we have an in-flight patch that's going to add that. Another thing we've done and we're intending to do more of is originally we would always unconditionally reboot into IPA before attempting any firmware operations. Because we're doing it out of band, we abandoned the initial reboot just to save a little bit of time. And there are facilities in Redfish which allow us to track reboots without actually running the RAM disk. So we'll explore using that further to reduce the runtime of the updates, because right now you need a couple of reboots, as you've seen. If we can remove some of that, it will just be faster applying updates, which is something that will make some users happy. And we'll look into possibility of applying multiple updates and settings changes at once. This is not something we recommend right now. Some servers deal with that, some servers do not, so we might need to look into making some improvements so that it's more uniform. Again, the goal here is to reduce the overall operation time. If someone wants to patch all the firmwares and change the settings, just trying to make it faster for the users. So that's on our roadmap. In our previous session, we haven't had a chance to share the Etherpad link, so I just wanted to share it with you. If you're interested in this feature or any other features, please join us. You're most welcome. You can contribute. You can shape the direction of the discussion. So if you'd like to be involved with the Ironic community, here is your chance. Feel free to copy the link and please join us. The PDG will take place in a couple of weeks, I believe.
Essentially the week from Monday.
Yeah, so pretty soon. So yeah, if you're interested in any of that, you're most welcome to come and help us. And with this, I would like to acknowledge my colleagues who have been a great help implementing the feature. Some of whom are here with us. And I would like to open floor to questions. If you have any, also feel free to grab our emails and contact us offline, but if you have any questions, now is your time.
Where did you store the firmware image? It's specific to OpenStack, or I can use any HTTP server?
The latter, yeah. You can use any HTTP source that is accessible for the BMC. You just need to make sure that the BMC can connect. So it's not the in-band, it's the out-of-band. So if the BMC can fetch the image, it's going to work. Currently, we don't provide a web server that's hosting that images. It might change in the future, but right now it's like you described. You set up your own HTTP server, and that's the firmware image source.
So it's on my own to keep like a track of which image should be used for each server, right?
Yeah.
So, you know, like,
So the assumption is that you work with the vendor to source the images that you're intending to use. Ironic will track what image you have installed and what was the original one, so you see the versions, but we only do that much. We don't validate the image in any way. It's essentially something we leave with the vendor and the PMC, which is the middleman who applies the image onto your hardware.
thanks.
The examples I saw were all Dells.
Yep.
I'm assuming this works with anything that would support like the Redfish interface, so like Supermicro or anything like that. Do you know if there's been any testing done on that?
Yeah, we've done testing on Dell HP. We've done a little bit on Supermicro, I believe, but probably it's less tested. Essentially, if it has a relatively reasonable Redfish implementation, it should work. But again, as we mentioned in previous sessions, Redfish has a fair bit of gears. So if we're dealing with some not so standard Redfish implementation, there might be issues or there might be some work required. But it's not our intention to only support one vendor. We're trying to support any reasonable Redfish implementation that we can. Good question.
You mentioned the service is built for running on active nodes.
Yes.
Is there also an idea of being able to call service on a node that is currently offline or in maintenance itself, or is this more like node and use the cleaning approach for that?
Yeah, I would say for those cases use cleaning. Would you agree with that?
I mean, it's just because of the if you deprovision a node, it's more like I need to shut it down for whatever, changing disks anyway. So maybe I can also implement a few firmware upgrades and then going back to the initial booted image. If I do the unprovision, then I basically need to redeploy the whole node again. That was just the idea of that. But
Right. So from me, the line of separation would be whether it has a deployed image. Like if it's imaged but powered off, that would still be servicing. But if it's not imaged, that will be cleaning.
Yeah, so there's also an interesting angle here. I don't know if you were on the previous presentation by Jay, but there are some special service steps. So service steps are just framework. It's not limited for firmware upgrades and settings. And there are steps like hold, which just pauses the whole process and does nothing to the node anymore, which is when you can do manual stuff and then you unhold and the next operation runs, which could be for upgrades. Right, there's also steps like power off, power on, where you could, for example, force it to power off, do your power off, hold, do your manual thing, unhold, and it automatically goes to the next step or back to active. So
currently we use the power off and then we set them just to maintenance, which basically makes you ironic ignore them.
Right.
And then later on, once we're finished, we just undo the maintenance and power them on again.
Right. So I'm basically offering a slightly different angle to that, because in maintenance we're really trying not to do anything with the nodes. So like servicing and maintenance are not going to play well together. But maybe you can look at this as hold unhold approach instead.
Sounds good. Thanks.
Yeah. And from the state transition perspective, I'm not sure it would allow servicing for maintenance. I'm not sure we have state transition.
I think you will face a few problems because we don't allow heartbeats, for example. So it's not going to work well out of the box. You may have to tweak things a bit. Maintenance is really stuff like, oh, even BMC cannot be reachable anymore and stuff like this. I took out the server out physically and stuff like this. If you just need to intervene less dramatically, maybe hold on hold.
Yeah, sounds good. Thanks.
Great question. Thank you. Any more questions? Thank you for your attention. Thank you.